Now we're going to look at how to find the inverse of a 3 by 3 matrix. And this is a very intense, drawn-out process with lots of places to make a little computational error. So being able to get through to the end of this without making a mistake is actually quite an accomplishment if you're trying to do this by hand. So the first thing that we have to do, I'm just going to outline the process right now. The first thing that we have to do is create what's called the matrix of minors. I'm going to show you how to do that by finding a bunch of smaller determinants here in part 1 of this video. Then we will write what's called the cofactor matrix. We will write that by taking the matrix of minors and bringing that sign matrix that I talked about in another video back into play to change the signs of some of the numbers in this matrix of minors. Then we will go ahead and find the determinant of the original matrix A. Once we have that, we will write what's called the adjugate matrix. It is the transpose of the cofactor matrix. We'll talk about that when we get there, but the transpose just switches the rows and columns. So the first row becomes the first column, the second row becomes the second column, and the third row becomes the third column when you're finding the transpose. And then finally, we'll do a little bit of scalar multiplication. We'll take that 1 divided by the determinant, and we'll multiply that by this matrix that we just created in step 4, and that should produce the inverse of the original 3 by 3 matrix. So like I said, it's a rather long and drawn out process. There's lots of places for you to make a mistake, but let's just go step by step. You may have to communicate with me and have me check each step along the way. Did you do this right? Did you do this right? And so on if you're not getting it correct in the end. So let's go ahead and look at step 1, writing the matrix of minors now. So now I'm going to look at how to find and create what's called the matrix of minors. We're going to set up a bunch of smaller 2 by 2 determinants. I'll show you how to create those, and then we're going to go through and evaluate all of those, and those new numbers at the end will form a new matrix known as the matrix of minors. So the first thing I'm going to do to figure out this first entry in my matrix of minors is I'm going to take the entry that's in the first row and first column, and I'm going to cover up the row and column containing it. So cover up that column, and I will cover up that row. And I look at the numbers that are left, and they form a smaller 2 by 2 matrix, so I will have the determinant of that matrix 0, 4, 2, 5 as my first entry in my matrix of minors. I'll evaluate that determinant later. I'm just going to set it up for right now. And then I move over, and I will cover up the second number there, so the first row and the second column now, and I see these other numbers that are remaining that will create another smaller determinant. So I have the determinant of 2, 4, 0, 5. And then finally, we'll cover up the third column there, create this smaller determinant of 2, 0, 0, 2. Like that. And then I will fill in the second row the same way. So I will go back and I will cover up the second row. And I'll go back and do the first column. And I have this new smaller determinant here of 1, -1, 2, and 5. Those are the numbers that are remaining. Hopefully you're starting to see the process of what I'm doing here. Move this over, cover up the second column. I'll have this new smaller determinant with numbers 2, -1, 0, and 5. And finally move this over to cover up the third column, and I'll have this new smaller determinant of -2, 1, 0, and 2. And now finally I'll move down to the last row. Cover up that last row and the first column, and I have this new smaller determinant of 1, -1, 0, and 4. Move over, cover up that second column. I have this new smaller determinant of -2, -1, 2, and 4. And finally, move over to cover up that third column, and I have this new smaller determinant of -2, 1, 2, and 0. And at that point, I've set up all of the smaller determinants I need to compute to arrive at the matrix of minors. So now you just have to remember that when you compute the determinant of a 2 by 2 matrix, Let's start with this first one here. You multiply the numbers here on this main diagonal together. So 0 times 5 would be 0, and then you subtract the product of what you get on the other diagonal. So here 2 times 4 would be 8. So when I did 0 times 5 and got 0, and 2 times 4 and got 8, and I do 0 minus 8, that gives me negative 8. So evaluating this first determinant to get my first entry in my matrix of minors, it should be negative 8. Now, moving on, evaluating the next determinant, 2 times 5 is 10, minus 0 times 4 is 0, 10 minus 0 is still 10. So that second entry there should be 10 after evaluating the determinant of that smaller matrix. Looking at this one, again, 2 times 2 is 4, minus 0 times 0 is 0, 4 minus 0 is 4. So this final entry here is 4. 6 more little determinants to evaluate. 1 times 5 is 5, minus 2 times negative 1 is negative 2. Careful with that one. 5 minus negative 2 actually becomes 5 plus 2. So this entry right here should be 7. 2 times 5 is 10, minus 0 times negative 1, which is 0. 10 minus 0 is still 10. So this entry should be 10. Negative 2 times 2 is negative 4, minus 0 times 1, which is 0. Negative 4 minus 0 is still negative 4. So this final entry in this row should be negative 4. We're 2/3 of the way done with part 1. Now, down here, again, evaluating this smaller determinant, 1 times 4 is 4. 0 times negative 1 is 0. 4 minus 0 is still 4. Negative 2 times 4 is negative 8. 2 times negative 1 is negative 2. Again, be careful here. We have negative 8 minus negative 2, which becomes negative 8 plus 2, which should be negative 6 for that. And finally, one more determinant to evaluate before we have our matrix of minors. And then we've completed step 1 of finding the inverse of this 3 by 3 matrix. Negative 2 times 0 is 0, minus 2 times 1, which is 2. 0 minus 2 is negative 2. So this last determinant here should evaluate to negative 2. And at this point, assuming I didn't make any mistakes along the way, because there's a lot of places to do that, I have created what is known as the matrix of minors, and therefore completed step 1 in finding the inverse of this 3 by 3 matrix by hand. And now we're going to look at step 2, where we go ahead and write what's known as the cofactor matrix. But before we do that, I actually did make a slight mistake in step 1. I caught it before moving on. So I want to talk about it. Back here when I was evaluating this determinant, I should have had negative 2, negative 1, 0, 5. And when I multiply that, negative 2 times 5 is negative 10 minus 0. Negative 10 minus 0 should be negative 10. So I should have negative 10 for that middle entry there in my matrix of minors. I think I had 10 whenever I did it in part 1 of the problem. So let's fix that there. Now that we have fixed that, here we're looking at our matrix of minors. We want to go ahead and turn this into the cofactor matrix. What we have to do that is actually quite simple. There's not a lot of work involved. We have to remember our sign matrix from before, where we had plus, minus, plus, minus, plus, minus, plus, minus, plus. And what this tells us to do is change the sign of any number that is in a position where there is a minus here. Think of all these minuses as meaning the opposite of. Think of all these pluses as meaning the same as for that. So to go ahead and find what's called the cofactor matrix, I'm going to take this matrix. Anything that's in a position where I see a plus sign, I will leave its sign exactly as it is from the matrix of minors. Anything that's in a position where I see a minus sign, I will switch its sign to the opposite. So I have a plus in the first position, so negative 8 is going to stay the same. I have a minus in the second position, so this sign is going to change to become the opposite. So that will become negative 10. I have a plus here, so this will stay the same. Moving down to the next row, I have a minus, so this will become the opposite. A plus, so this will stay the same as it is. Again, it doesn't mean it becomes positive, it means it stays the same as it is now with that. And then finally here I have a minus, and I have a minus there. Again, the minus means it becomes the opposite, so that becomes a positive 4. And then finally with my bottom row, I have a plus, minus, plus, so it stays the same. becomes the opposite, stays the same for that. And at this point, we've created what is called the cofactor matrix with these entries -8, -10, 4, -7, -10, 4, and 4, 6, -2 in the rows respectively. That's the cofactor matrix. And we've completed step 2 of finding the inverse of this 3 by 3 matrix, which takes a while if you can't tell. This brings me to step 3. It's time to go ahead and find the determinant of the original matrix A. Again, make sure you're clear that I'm talking about the original matrix A. This is not the matrix of minors. This is not the cofactor matrix. I'm going back to the original matrix A, and I need to find its determinant. So you need to pick a row to go ahead and use here. Again, I recommended when we were finding the determinant of 3 by 3 matrices, pick a row to use that has the most number of zeros in it if possible. That'll cut down some of your work. So I'm going to go ahead and just pick that last row there. Remembering my sign matrix from a second ago where I had plus, minus, plus, minus, plus, minus, plus, minus, plus. Those signs are going to become important as I try to set this up. So if I'm going to use the last row, I'm going to take this 0 times the smaller determinant. And again, that smaller determinant is going to be created by crossing off the row and column, or as I covered them up, the column and then row. So I have 1, -1, 0, and 4, like that. Then I will go to my next number in my row. Again, I'm choosing to use the bottom row. That was just a choice that I made. You could certainly use any row to do this. So I see my next number is 2 in that. I see the sign over here in the sign matrix needs to make that the opposite, so I have -2 times a smaller determinant, and I need to cross off the row and column that contained my 2. And I see I have these numbers left, -2, -1, 2, and 4. And then finally, the last number in my row that I chose to use is 5. I see there's a plus sign in that position, so it stays the same. And then I need to make that smaller determinant, again, by crossing off the row and the column that contained that 5. That leaves me with -2, 1, 2, and 0. So now I just have to go through and compute all of these smaller determinants. The good news for me, I chose a row that had a 0 in it, so I don't even need to do that one because 0 times whatever that determinant is will be 0. So I just have 0, and then over here I have a -2 times, and when you do your determinant, remember, it's -2 times 4, which is -8, minus 2 times -1, which is -2. Get the double negative in there. 5 times -2 times 0 is 0, minus 2 times 1, like that. And evaluating this, I have 0, and then in here I have -2 I have -8 plus 2, which is -6, times -2, which is +12. And over here I have 0 minus 2, which is -2, times 5, which is -10. And evaluating this determinant, 0 plus 12 is 12, minus 10 is 2. So step 3 is now complete. I now know what the determinant of matrix A was. The determinant is 2.